Hi, this is Pranjali. Today I'll be discussing my project topic, which is topic modeling in NLP using LDA, which is latent digital allocation. Let's start with the problem statement and challenges faced. So, topic modeling basically provides us a method to organize, understand, and summarize a large collection of textual information. It helps us, discover the hidden patterns which are present among the collection. So for us to take an example, we can take an example of either the news articles or academic articles or the emails as is shown in the picture. Topic modeling will reveal the patterns and it will assign the topics according to the content, and it might be possible that more than one topic can be associated to a single content or a document. So it is probably best to think that topic modeling is not a way to get the topics, but as a way, it's actually a way to generate the insights and particular semantic behavior uh, within amongst the provided documents. So also the challenge is that the idea of a topic is very fluid when it comes to topic modeling, because a single document or a single collection of a document can a single document can belong to more than one category. So topic modeling essentially helps us give a score or a probability score to different topics which we have categorized into, so that will not uh, it will not essentially categorize it into a single topic as such, but it will allocate scores based on the words present in the document. So my main motivation for selecting this topic as for my project was because I took intro to natural language processing during my last semester under Professor Dr. Punescu. I found all my assignments interesting, and I wanted to explore more and implement the ML concepts which I've learned during this class. So yeah. Okay, if we have to talk about some existing approaches, so we have a couple of frequently used existing methods for topic modeling, which include latent semantic analysis, latent Dirichlet allocation, non-negative matrix factorization, random projection, principal component analysis. Also, as I found it by going through this article, which I've mentioned in the reference link, they would when we compared when they compared two textual data sets to evaluate the performance of topic modeling methods based on the topic quality and some standard statistical evaluation metrics like recall precision, F score, and topic coherence, latent Dirichlet allocation and non-negative matrix factorization were the best amongst them. So I decided to go ahead with implementing LDA for my project as well. Methodology. So I've used LDA, which is clear from my previous slides. LDA classifies the text inside the document to a particular topic. How it works is it basically works on two kinds of models. One is a topic per document model, and the other one is words per topic model, which are modeled as Dirichlet distribution, which is essentially a multivariate probability distribution. So each document is modeled as a multinomial distribution of topics, and each topic is modeled as a multinomial distribution of words. These two models are built during the LDA process. So LDA assumes that every chunk of text which we feed into it will contain words that are somehow related. So which is why we also do some pre-processing on the data. Also, this emphasizes on the fact that choosing the right corpus of data is crucial, because every chunk of text is being taken into consideration when we are using LDA. It also assumes that the documents are produced from a mixture of topics. So in the end, when we get the results, which will be seeing in the coming slides, we get a group of probability scores for each of the topic, and probability scores for words which are allocated to each of the topics. So yeah, so So the topics, as is mentioned in the slide as well, the topics then generate words based on the are generated based on the probability distribution. Okay, now focusing on the right hand side towards the picture. So this is simply how the flow for my project also works. We start with the input. There are a couple of data pre-processing steps which will be discussed in the next slide, followed by implementing the LDA model on the processed data, and eventually we get a list of topics with a list of topics with different words associated with each of the topics. So yeah, coming to the data pre-processing steps. So the first one is tokenization. We split the text into sentences, and sentences are further split into words. We lowercase the words, remove the punctuations, and these data cleaning steps are done as a part of the tokenization step. Then the second steps is once the data has been tokenized, we perform a stop word removal, which is where we removed all the words which do not add any value to the actual context of the document. So words that have fewer than 3 characters, which is like is, the, etc., are removed. So then the next step is lemmatization. So words are lemmatized, which means that words in the third persons are changed to first person, and verbs in the past and future tenses are changed to the present tense. So for example, called will be changed to single word call. Yeah, followed by next step, which is stemming. So words are stemmed, words are reduced to their root form. Then followed by bag of words on the dataset. It essentially creates a dictionary from the processed data containing the number of times a word appeared in the training set. For my project, I've used Genism's corpora or dictionary function for this, followed by some more filtering on the data, which involves creation of dictionary, removal of rare and common words, converting list of words into bag of words document format. Moving on to the results and observations, I've included the result from how the topics were classified. I've included a screenshot of an example test data, how the topic was allocated to it. Third is coherence score, we'll talk more about it, and followed by the visualization of topics. Classification of topics. This code snippet shows how the LDA model eventually classified into 4 topics, or so for each topic we can see the words occurring in that topic and their relative weights. So when we can see, I've given number of topics as 4, since I knew that this was the 4 main class of data which was being fed into it. So yeah, we can see for topic 0, it includes the words which are related to business. So we, at the end, I have mentioned the name for each of the topic, how it classified. So topic 0 represents the business documents, topic 1 represents the documents related to politics, topic 2 to technology, and topic 3 to entertainment. Second topic assignment. Here is an example from the test data, how it assigned the scores for each of the topic. As we can see this, the text which is present in the document is related to business, so it eventually assigned a higher score for topic 0, which was business, and these are the scores for each of the words which it found inside the document. And yeah, I also calculated the coherence score, which is basically a measure of how similar the words are to each other within the topics which we have seen so far, and it basically measures how interpretable the topics are to the humans. So coherence score for my model came out to be 0.53. Also, I ran a couple of experiments on the hyperparameters for LDA model to come up with the optimal coherence score. So this is, for now, I have a coherence score of 0.53. Nextly, I've included a visualization of the topics. So I've used PyLDAVS module for this. So it gives us an interactive dashboard kind of, which includes the intertopic distance map, while when you can hover over each of the topic numbers 1, 2, 3, 4, and you can see the data accordingly. So on the right hand side, we can see for topic 1, which is selected for now, what are the top 30 most relevant terms for the topic, and also we can adjust the hyperparameter lambda for each of the topics to see the results. So this is one of the good libraries to get a better visualization of the data which you have trained upon. So yeah. Um, Finally, conclusion and future work. So I was able to perform topic modeling using Jensen's LDA and visualize the topics using PyLDAVS module. After analyzing and testing the outputs of coherence score against the number of topics, I was able to select the optimal value for the number of topics for my dataset, which was 4. For future work, I can try with different text pre-processing methods to check the performance. I can tune in LDA hyperparameters such as number of topics, alpha, beta, to try different coherence metrics. So yeah, I've also included the references and useful links for my projects. Yeah, thank you.